Assalamualaikum. A good day to all of you. So now, if you are asked to expand this expression 2 plus 3j power 4, how are you going to do it? Is it possible if you want to expand one by one? Yeah, it's possible, but it takes a lot of work. So now, I will show to you the more simple way on how to do it. Okay, I want to introduce the binomial theorem. So if n element of natural number, meaning 1, 2, 3 and so on, then a plus b power n is equals to this formula. For example, if you have a plus b power 2 then your n is equals to, sorry, 2 is too small, power 4, okay, n is equals to 4. So it will be, we follow the formula a power 4 plus 4c1 a, 4 minus 1 is 3, b plus 4c2 a 3 2 b power 2 plus 4c3 a, 4 minus 3 is 1, b power 3 plus 4c4 b power 4. So we stop when we get 4c4, meaning ncn. So what is nc, nc1, nc2, nc3? So it's actually function in your calculator, ncr. Okay, you just press that one, okay, use that one. Okay, so you can calculate it. So it will be a power 4, meaning you want to simplify. Okay, so 4c1 okay, you press 4 and then shift, divide key and then 1, 4c1 you get 4, a power 3 b plus 4c2 you press 4, shift, divide key 2, 6, 6a squared b squared plus 4c3 is 4 ab power 3 plus 4c4 is 1 b power 4. So this is the result of your expansion. If there are same expression, you can add them together. So but normally you get the simplest form. Okay, let us try this exercise. Expand using binomial theorem, then write in standard form of complex number. Let's try for a first. For a, n is equals to 4, a is equals to 3, and b is equals to 2j. So the binomial expansion, okay, we follow the theorem. 3 plus 2j power 4 is equals to a power n. So n is 3, n is 4, a is 3, so 3 power 4 plus nc1, 4c1, a power 3, b power 1 plus 4c2, a power 2 sorry, your a change, 4c1, and then a is 3. So 3 power 3. B is 2j. 2j power 1 plus 4c2. 3 power 2. 2j power 2 plus 4c3. 3 power 1. 2j power 2 plus 4c4. 3 power 0, which is 1, so no need, plus 2j power 4. That's it. And then we will simplify it. 3 power 4 is 81 plus 4c1. 4c1 is 4 times 3 power 3 is 27. 2j power 1 is 2j plus 4c2. 4c2 is 6. 3 power 2 is 9. 2j squared will be 4j squared, which is negative 4. Plus 4c3 is 4. 3 times 3. Here should be 3, sorry. Will be 2 power 3 is 8. Negative 8j. J power 3 is negative j. Plus 4c4 is 1. 3 power 0 is 1. 2j power 4. 2 power 4 is 16. J power 4 is 1. So the answer is 16. So you can simplify it. 81 plus 216j plus or minus 216 minus 96j plus 16. And then you can simplify j with j and a and b. A if the terms without the j, b is the term with the j. So what's the final answer? The answer is negative 119 plus 120j. So that's it. Yes, write in standard form. A plus bj. So your A for the first one is z is equals to 119 plus 120j. So now let us do for B. For B, your A is equals to cos theta, B is equals to j sin theta, and N is equals to 3. So B cos theta plus j sin theta power 3 is equals to, okay, first A power 3 because N is 3. So cos theta power 3 plus 3c1 cos theta power 2 times j sin theta power 1 plus 3c2, right? A is cos theta power 1 right, and then sin theta, sorry, j sin theta power 2 plus 3c3 cos theta power 0 j sine theta power 3. That's it. And then you simplify it. So cos theta power 3 can actually be written as cos like this, cos 3 theta. So it's understood that it's belong to all. 3c1 is 3 cos squared theta sine theta. Okay, j we put here to avoid confusion. Plus 3c2 is 3 cos theta power 1 is cos theta. J squared sine theta squared is sine squared theta. J squared is negative 1. So we change it to negative here. Plus 3c3 is 1. Cos theta is 1. And cos theta power 0 is 1. So J sine theta will be sine squared theta. Sorry, sine cube, sine power 3. Theta J power 3 will be negative 1 times J is negative J. So we change it here, will be negative J. So now you can simplify it. We can combine. Or we rewrite again. Okay, we combine a term with no J, which is A, and term with J. Real and imaginary, because we want it in standard form. So it will be okay, like this. Cos theta power 3 minus 3 cos theta sine squared theta plus. Okay, this is plus, 3j. Okay, 3 cos squared theta sine theta minus sine theta power 3. Don't forget the j. Okay, so now it's already in standard form. That's it. So basically we just follow the binomial theorem. Okay, now you can try to do this exercise 1.16 and see whether you can get the correct answer or not. Okay, if you have any problem, just let me know. So why do we need the binomial theorem? Actually, binomial theorem is very useful. For example, if you want to state this one cos theta power 5, so which method you want to use, whether it's finding roots, De Morgan's theorems, or should we just expand it, okay, to find cos theta power 5. Okay, now to solve for cos theta power 5, actually we need this theorem 5 and theorem 6, which is binomial theorem. Okay, theorem 5 states that z is equals to cos theta plus j sine theta. Then z power n plus 1 over z power n is equals to 2 cos n theta. Zn minus 1 over zn is equals to 2j sine n theta. So we are going to use this later. And also the binomial theorem that we have learned before. Okay, this example cos theta power 5, we want to state it in terms of cosines, meaning cos. So by applying theorem 5 and binomial theorem. Okay, so cos 5 theta is equals to z plus 1 over z. And 2 cos theta power 5 is from theorem 5, both are from theorem 5. So first, expand left hand side using binomial theorem, and then expand the right hand side. Okay, so this is the left hand side, this is right hand side. Okay, so we equate left hand side and right hand side, and then we simplify it in terms of, so that is written in terms of cosine. So if you're wondering how we get the So if you are wondering how we get this, so it's from theorem 5 just now, which said z power n is z power n plus 1 over z n is equals to 2 cos n theta. So since this one is cos, so we take cos. So here is 1. So n here is equals to 1. Okay, cos theta, not cos 4 theta, 3 theta. So n is equals to 1, only 1 theta. So here, meanings, when n equals to 1, it becomes z power 1 plus 1 over z power 1 is equals to 2 cos theta. That's why we get this one inside here. And also this one. And then here is the power 5. So we put 5. Power 5. So that's how we get this one. So meaning we substitute, okay, from the original here. And then we rewrite again using theorem 5 like this. And then we will expand the left hand side here using binomial theorem, which I will show in next slide. Okay, so now let us expand the left hand side. Okay, so it is z plus 1 over z power 5. So we will use binomial theorem with n equals to 5, a is equals to z, and b is equals to 1 over z. So the formula is a power 5, so z power 5 plus 5c1, right? A is z power 4, 1 over z power 1 plus 5c2 z power 3, 1 over z power 2 plus 5c3 z power 2, power 2, 1 over z power 3 plus 5c4 z power 1, 1 over z power 4 plus 5c5 and z power 5. Z power 5, 1 over z. Oh, sorry, z power 0. Z power 0, 1 over z power 5. That's it. So let us simplify this. So z power 5, 5c1 is 5, z power 4, z power 4 with z power 1, so it becomes z power 3. Okay, plus 5c2 is 10. Okay, z power 3 with z power 2 will be z power 1. Okay, we can cancel this one and this is become 1 plus done. So 5c3 also 10. Z power 2 is 1 over z power 3, cancel, this one becomes 1. So 1 over 10 over z. And then plus 5c4 is 5. Okay, z with z power 4, so it becomes z power 3. Right? And then plus 5c5 is 1. So z power 0 is 1. Then 1 over z power 5. So it will be 1 over z power 5. So if you want to simplify this, okay, we see we have two terms with z power 5, two terms with z power 3 and two terms with z power 1. So we collect them together. So 10 z plus 1 over z plus 5 z power 3 plus 1 over z power 3 plus z power 5 plus 1 over z power 5. Okay. Okay, now we apply again theorem 5. So it will be 10 z plus 1 over z is 2 cos theta, and then plus 5, okay, z power 3 will be 2 cos 3 theta, okay, from the theorem here. And then this one will be 2 cos 5 theta, okay. If you already forget, this one z power m plus 1 over z power n is equals to 2 cos n theta. So we apply this theorem, yeah? So that's how we got this. So you can rewrite again. It's 20 cos theta plus 10 cos 3 theta plus 2 cos 5 theta. So this is the result of the left hand side. So now what's about the right hand side? So the right hand side is just cos 2 cos theta power 5, right? So this one we just expand 2 power 5 cos theta power 5. So actually we get 32 cos theta power 5. So now we equate left hand side equals to right hand side. So the left hand side just now we get 20 cos theta plus 10 cos 3 theta plus 2 cos 5 theta. So it's equal to the right hand side, which is 32 cos theta. So the question just now is cos theta power 5. Where is it, right? So now we will write in this form. So we will move 32 to the left hand side. So now we change, cos 5 theta is equals to, okay, we divide. So this 32 here is multiply. So we bring to the left hand side. This becomes divide. So 20 over 32 cos theta plus 10 over 32 cos 3 theta plus 2 over 32 cos 5 theta. So the answer will be 1 over 16 cos theta sorry 5 over 8 cos theta plus 5 over 16 cos 3 theta plus 1 over 16 cos 5 theta. That's it. We have completed. This is what we call representing cos theta power 5 in terms of cosine, because we have all cosine. So if you want to represent in sine, so you have to use z power n minus 1 over z power n is equals to 2j sine and theta. Okay, for sine and theta. If you want to express in sines. Okay, that's it. Okay, for this example, we want to find by using de Moivre's theorem and binomial theorem, we want to prove this equation. Yeah. So we will start from this sine 4 theta by using de Moivre's theorem, and then at last we will get this. So how? Let's start with de Moivre's theorem. So by applying de Moivre's theorem, okay, this one DMT. So if cos theta plus d sine theta power 4 is actually cos 4 theta plus d sine 4 theta. So the terms that you want is here. That's why we power 4. Okay, because we want this. So now we expand the left hand side here by using binomial theorem. If you still remember, so this is A, this is B, this is N. So when we expand, at last you will get this. I will not show again because I've shown in the previous example. So in the end we get this. So you separate the term with no j and the term with j, meaning you separate in standard form. Z equals to A plus B j. So next, okay, so we want j sine 4 theta. So we will equate cos theta on the left with the one on the right. Okay, we compare cos theta compare with this one. J sine theta compare with this, because this term is real with real, imaginary with imaginary. Okay, or the term with j with term with j, terms without j with terms without j. Okay, since we only want this j sine theta, you want sine theta, right? So we will look at this. Okay, when we compare, okay, from one is not the, this one is the right hand side, right? The right hand side of one, right hand side of one. Okay, so when we compare with the left hand side, okay, when we expand using binomial theorem, so we compare cos 4 theta is equals to this, j sine 4 theta is equals to this. So since the equations as, okay, cos 4 theta is equals to this, sine 4 theta is equals to this. Okay, we can cancel the j. So sine 4 theta is this one. This is the answer actually. Okay, we only want sine 4 theta as been asked by the questions. Okay, that's it. So there are two different things, two different expansions that you need to know. First one is sine and theta or cos and theta, and second one is sine and theta or cos and theta. Okay, so this one is using theorem 5 and binomial expansion. This one using de Moivre's theorem and binomial. So you need to look carefully on the questions, which one the questions want. Okay, that's it. So now there's exercise for you. So using appropriate theorems I've shown before, you can try to do this exercise.